This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 125. Happy holidays and Happy New Year. This will be the last Satellite Book Club seminar for the 2022 calendar year. But we're looking forward for more book clubs coming up in 2023. But before we close out for the year, today's presentation, using PGEN in synoptic and mesoscale analysis. We're glad to have presenters Carl Jones, meteorologist from the Grand Forks, North Dakota Weather Forecast Office, and Dylan Flynn, meteorologist and surface analyst for the National Hurricane Center and Tropical Analysis Forecast Branch. Our facilitator for today is Mike Stavish, the Science and Operations Officer from the Medford, Oregon Weather Forecast Office. Just a few reminders, as you just heard, this session is being recorded. There will, as always, be an opportunity for Q&A after the presentation, and we particularly encourage attendees from our forecast office and regional headquarters to post your questions in the chat, and we will field them in the order they are asked. If you have signed in with an office account or not using your full name and wish to ask a question, please state your full name in the chat box when asking your question. That way we can follow up if necessary. Also, as a reminder to check your spam folder if you are looking for TowerS communications. We've heard from some of our participants that the TowerS communications are getting categorized as spam. Of course, we want no one to miss any news on the Satellite Book Club or any other information that the TowerS team is sharing. We're always looking for future presenters, so if you're interested in sharing an application with your colleagues, please contact the TowerS team. And we particularly encourage presentations that you may have prepared for AMS or the NWA. Maybe they're not solely focused on satellite imagery, but satellite is a part of them. We'd love to have them as part of this seminar series. And if you're looking for training materials on satellite or otherwise, contact Brian Mata for any information or questions on that. Also, I hope you will consider joining us tomorrow for the TowerS quarterly update, where you will learn more about GOES 18 becoming GOES West on or around January 4th, 2023. If you are unfamiliar with the TowerS quarterly update and would like to attend, please contact the TowerS team or visit the link in the chat. There's a link to a Google Meet, and that will be tomorrow at 1 p.m. Eastern time. So if you're looking for more information, you may have heard GOES 18 will be replacing GOES 17. That will be permanent on January 4th. And if you are getting your data from the Satellite Broadcast Network or the GRB, that switch will commence at around 18 UTC, and including the sectorized cloud moisture imagery, the L2 derived products, and other products such as composite imagery. So very exciting time. It's been a very exciting 2022. I would like to thank our TowerS team, particularly Kushad Bowman and Lee Byerly, the Office of the Chief Learning Officer, the GOESR JPSS program, our facilitator and presenters for today. Without further ado, let me introduce Carl and Dylan. First, starting with Carl, who's a meteorologist at the Weather Service in Grand Forks, North Dakota. Originally from Jacksonville, he received his bachelor's in meteorology from Florida State University in 2012, and his professional focus is in road weather and satellite applications, but his personal focus resides in family, photography, cooking, and getting outdoors. Hopefully it's not going to be too cold for you coming up here, Carl. Dylan is a meteorologist and surface analyst with the Tropical Analysis and Forecast Branch, TAFB, at the National Hurricane Center in Miami. His main job is to create surface analyses and to coordinate on the borders with the Weather Prediction Center, Ocean Prediction Center, and WFO Honolulu to create the Weather Service's Unified Surface Analysis, which covers the majority of the Northern Hemisphere. Dylan grew up in Seattle, went to the University of Washington, and served as a Naval Meteorology Oceanography officer before joining the Hurricane Center in 2021. So this is certainly going to be a great satellite book club. We're glad to have Carl back. And Dylan, welcome to the book club.
Hey, thanks, Jordan. Happy to be here. So I'm going to just kind of go over really quick here what we do as surface analysts for the Weather Service. and who that involves. So right now we're looking at the Ocean Prediction Center's Unified Surface Analysis website, and this shows that we actually analyze the majority of the Northern Hemisphere. So over here we're looking at the Philippines and even into Japan and a lot of Siberia, all of the North Pacific, North America, Greenland, all of Central America, parts of South America, the Atlantic, the majority of Northern Africa, and the majority of the Mediterranean and Europe as well. So it's a pretty expansive area that we cover with these analysis. And as far as my area, TAP B, we just do south of 30, east of 140 west, and then all the way over through Africa. So we basically do the tropics. Honolulu, the one WFO that helps with this, does this portion of the Southwest Pacific, and then the Ocean Prediction Center has a Pacific analyst, an Atlantic analyst, and then obviously WPC does North America. So there's 5 people that coordinate every 6 hours to create this big map. And something that's really cool here is you can actually loop it here, and this shows the loop of every analysis we've done for the last 14 days. So you kind of track a feature in time, and of course my mind jumps to all the little errors I see, but overall it's actually pretty impressive that there's this much continuity. Every 6 hours or so we have a whole new set of 5 people analyzing, and it's pretty continuous. So a lot of coordination goes on to make it look this smooth. And then there's different views. So here's Ocean Prediction Center, their view, and they add some things here that you didn't see on that big map, like warnings and central pressures, and where low centers are going to move within 24 hours. Same thing for TAP B. We just have a different area that we zoom in on. It's all based on the same data though. So WPC, same thing. They have their high resolution one with more observations on it because they have more observations. But it's all the fronts are in the same spot on all these maps. And you may be more familiar, so I'm just on Carl's website here, of the short range products produced by WPC. So these are typically like a 6-hour forecast or so, and they're just valid for the day. But again, these fronts are going to line up with where the analysis is. All of these fronts and features are drawn in something called PGEN, which is what we're going to talk about the rest of the session here. So how do I do the analysis? And I'm actually going to do one for you live really quick. So let's find a feature of interest here. And you might be thinking, what is that? What is that software you're using? This is NMAP, so it predates AWIPS, or at least AWIPS 2. And it's what we use at the national centers. Eventually we'll be on AWIPS, but we're not there yet. So the important part here is this box, this PG palette. This is going to be essentially the same in AWIPS as it is in NMAP. Okay, so all the buttons I'm pressing, all this functionality works in AWIPS as well. It just looks a little bit different. In fact, in some ways it works better in AWIPS than it does here. So okay, let's find a feature of interest. So this is just visible satellite from GO16 and then a lightning mapper as well. So I'm going to guess that there's a front right here that goes through the eastern Gulf of Mexico. So I'm just going to click on front, cold, and then I'm just clicking to put little inflection points. It's really easy. You don't have to be an artist to make something look good. And then we have some lightning out in front of it, so I might draw down here, squall line. Okay, so that would be my first guess, and then I would look closer at observations and zoom in to see if I got the front in the right position, and it doesn't look like I did. It looks like I was maybe a little fast due to the southerly winds here in Florida, so I'm just going to back the front up a little bit and go like that. And then since this is a satellite book club, another thing I'll look at is scatterometer. So let me see if we got a new pass. Looks like we're going to miss the front, unfortunately, with the pass today, at least the afternoon pass. But this is also helpful to find. So we have a large area of gale force winds. These are the blue winds up here in OPC's area. So, and we do issue gale warnings, so that's helpful to verify. They actually have a hurricane warning out on this system, and it looks like those winds are certainly going to verify for that system. All right, let me see my time. Okay, so that's the gist of it. Obviously, we look at models and other features as well. One thing that's kind of interesting is are isobars. So not only do we draw surface features, but we also do an isobaric analysis. And this might surprise some people, but this is how it starts. And I draw everything by hand. So I'm just looking right now at observations and the GFS pressure field. We draw every 4 millibars, and at least here in TAP-B, we draw it by hand. Further north, where they have more a tighter pressure gradient, they have some tools that kind of give them a first guess, but still all these isobars are drawn by hand, which may surprise some people. Looks like the GFS is doing fairly well here, but it has some observations in central Mexico that said it brought the 1016 line a little too far north. So that's just really quickly how we would do that. Now, a lot of times we'll see an observation that just doesn't make sense. And I don't know if everybody knows about this tool, but WPC maintains this website of pressure biases. So sometimes if we're trying to coordinate on the boundary or it just doesn't make sense with an observation seems wrong, this website, it's just an internal weather service website, will tell, based on our previous analyses and our pressure field that we analyzed as humans, how those pressure stations have fared. So are they always too low given what they should be based on where we're putting the line? So, and it goes back 30 days, I think, it makes an average. All the stations in blue are too low. So this station here in Southeast Louisiana is typically negative 2.9 millibars. So 2.9 millibars lower, we analyze at 2.9 millibars lower than the pressure thing. So if you're doing a mesoscale analysis, this can really help, especially if you're, instead of doing 4 millibars, maybe you're doing 2 or 1, and you can kind of get a sense there. So this is a really, really great tool that we use. And as I kind of transition here to, I'm going to hand it over to Carl for more of a mesoscale discussion and how he uses PGEN in his operations. I just got this email about an hour ago, and somebody was asking why we don't draw ridges on our map. Anyway, his question is not important. Somebody responded from the Raleigh office and said they do, once a day, they do their own hand-drawn analysis. So you can see a ridge down here through the Appalachians in the Mid-Atlantic. And they actually do 2 millibar, looks like they're doing 2 millibar pressure fields, and they're doing dew point lines, so isodrosotherms. But anyway, the point is they're drawing this by hand with colored pencil, which is great. It gives them more detail than what they're getting from WPC, and it's more of a mesoscale analysis. But if you can do this in AWIPS, which you can, then you have the ability to share it to other people in your office or outside of your office. They can put your map on and see where your features are, and it just makes it more. And you can save the file too. So rather than having to print this off and store it somewhere, it's just a lot simpler and cleaner. There is a learning curve, but this is a useful tool for anybody who does analysis or wants to start doing analysis to do it on AWIPS. Will save you a lot of time and make a better archive. And with that, I'll pass it over to Carl for how he uses PGEN at the local level in a more mesoscale analysis.
Okay, can everybody hear me?
Loud and clear.
All right. Okay, so yeah, that was really great to see that live demo that Dylan just provided for us. Unfortunately, I don't have that capability of live demoing right now with the current ongoing system in the northern plains and upper Midwest. Otherwise, I would. But instead of doing a live demo, grab some screenshots of actually some of the PGEN tools, or what it kind of looks like in operations of how we use PGEN in Grand Forks WFO operations just yesterday concerning this stalled upper low and the heavy snow that's that it came with it. I did have intentions of just giving a smattering of severe convective, more that warm season type approach of how we've used it, but we're not going to do that. It was too good of an opportunity to not show how we used it yesterday, and anytime I get to show any sort of winter weather, I'm going to do that. So here we go. All right, so starting, I was more or less, I guess you can call a meso analyst, but more or less, we were still, I was storm forecaster with another colleague of mine, and we were trying to gauge expectations of some current ongoing heavy snow. It was lingering a little bit later than what was previously expected, as well as we were expecting additional impactful weather, mainly from freezing drizzle due to dry slotting, as well as additional snow coming in from South Dakota from the deformation zone. So of course, when we're talking about this rather large scale extratropical cyclone, first place that I like to go to is water vapor analysis. So that's what we're looking at right now. This is one of my procedures, just a 4-panel. It includes GOES East, water vapor, the upper and mid channels. That's at the top right, or the top half of what we're seeing, as well as the air mass RGB that kind of gives like a collection of water vapor imagery, as well as it's really good at showing those PV anomalies associated with extratropical cyclones. Additionally, I like to supplement the water vapor imagery with model guidance, in this case the NAM, to get the rather large domain over the CONUS, looking at some parameters in the 500 and 300 millibar, including winds, geopotential heights. And I also enjoy not only just looking at the water vapor imagery from GOES East, and that optical sensor, if you will, but also the microwave type water vapor info from the advected layer precipitable water, and that's down there at the bottom left. And of course, at the surface, talking about PGEN, there's an overlay of the WPC surface analysis, and that's what we have available at the WFO Grand Forks is only looking at the WPC surface analysis fronts that update every 3 hours. So we use PGEN to essentially, if they're talking about this extratropical cyclone, we wanted to find the different conveyors, the low pressure center, and eventually a deformation zone that was going to be a feature of interest. So for instance, with the advected layer precipitable water product that we're looking at the bottom left, in this case, it's the 700 to 500 layer, and we kind of used this particular product in conjunction with the GOES water vapor imagery to try to get an idea as to where that moist conveyor is currently residing. We're trying to figure out where there was some ongoing heavy snow, and what was feeding into that heavy snow, and then kind of hopefully get some 1 to 3 hour forecast expectations, more of that meso analysis type region, just trying to gauge our expectations as what's going to happen, what's driving this type of hazard in the next 1 to 3 hours. And the moist conveyor in this dark green arrow pointing out of the Great Lakes region and into northern Minnesota and eastern North Dakota really gave us an idea as to where this particular elevated warm conveyor was. But in addition to that elevated warm conveyor, so we go down further into the surface, the ALPW surface to 800 millibar layer really showed that there was some additional rather rich moisture coming out of the Gulf of Mexico that was kind of trailing behind it. And we thought that was kind of interesting, and it really seemed like where these two types of moisture sources were feeding into this area of lift north of the low pressure center was really driving this area of heavy snow that's annotated in this imagery with the pink scallops. And as well, we were talking about the dry slot. We had we were interested in where this dry slot was, and we really kind of honed in on the nighttime microphysics. This is at 13Z, so we didn't really have a lot of daylight to work with right now. But with the lack of deeper cloud signature, this really gave an idea as to where the dry slot was kind of feeding in with not only the microwave or nighttime microphysics imagery, but it also kind of met our expectations looking at the water vapor imagery as well. So we kind of knew that this was going to, the dry slot was likely going to continue northward, kind of pushing the moisture source further north, so that helps guide our expectations that eventually this heavy snow was going to propagate to the north. Even though we were still getting a feed from the east, we still had confidence in this dry slot helping push that area of heavy snow to the north. And again, looking at some guidance and what we had been briefed on, we were really honing in this particular day, trying to figure out what this deformation zone was going to do. Currently annotated as the yellow dotted line in eastern South Dakota. So we want to keep tabs on that as to where exactly where that was and how it was propagating throughout the day. And we reflected these kind of thoughts. Now, a lot of internal discussion was happening, very meteorological, but you know, for our partners to get these types of get this type of information to our partners, we had the AFD as our venue of communication, and we didn't really necessarily use all the jargon that we you know, were discussing within the office, but nevertheless we were able to communicate these types of features that that was really helped illustrated by PGEN into our AFD. Moving a little bit further on into the day, this is now 21Z. As expectations were, you know, kind of met, the dry slot continued to push further north, as well as that area of heavy snow and the moist conveyor, or at least the elevated moist conveyor. But we were still noticing that the lower level moisture was still kind of, it really hadn't moved, which is kind of surprising. Well, maybe not surprising, but nevertheless, it was still kind of, you know, we were thinking like, oh, well, this could be a contributing factor to eventually maybe feeding into that depth zone that was expanding radially away from the stalled upper low and eventually into southeastern North Dakota. So this is just an updated image of around 21Z. That's one thing about PGEN. You know, if you're in this meso analysis role, you have to constantly be trying to update it and try to follow the features. But nevertheless, in my opinion, I think it's worth it following these features in real time to aid in your communication and illustrations. So that was kind of within the expectations of that the near term. However, as we started to look at guidance again, we noticed that there was this really large surge of heavy snow that was supposed to happen in the next 24 hours, which is actually currently happening right now. And we were actually a little taken back to see how large of QPF footprint was being placed over our area. And we wanted to know what was driving this, where the moisture was for this particular next round, if you will. And lo and behold, sure enough, we were able to see in water vapor analysis a shortwave in kind of near the Ozarks, the Texarkana area, as well as some really strong upper divergence, as you know, illustrated here with the localized upper jet. This is from the NAM, kind of showing that strong area of divergence, as well as the cooling brightness temperatures in water vapor, kind of showing where that current upper divergence and lift was going to be. So this, we had diagnosed our forcing mechanisms. We knew this was going to be our next player, and this increased our confidence in knowing that the large QPF footprint that was going to be with this next round was going to happen, and it increased it enough to change our thought process of kind of toning down messaging from the previous event, but rather issuing another winter storm warning and increasing our messaging for another round of heavy snow, it seems to be verifying looking outside. And of course, you know, at the surface with this WPC surface analysis, it was really great to see that there's that triple point kind of within Iowa, and a really large occlusion that was still hanging back in southeastern North Dakota, or southeast South Dakota. And it was at this point, this triple point, we had put our confidence further into this is going to be the next area of surface cyclogenesis. And when this was going to happen, the surface pressure gradient was going to tighten, colder air was going to continue to push eastward, and this increased our confidence in the potential for blowing snow impacts, which we hadn't seen so far in this event so far, kind of unusual for our area. But lo and behold, as this handoff was going to happen, it increased our confidence that blowing snow was going to happen. And again, just showing that our venue that we chose not only to discuss internally, but rather externally was the AFD. And yeah, so for the rest of the presentation, I hope we can have more of a discussion, just kind of use within of PGEN within WFOs or any other use of PGEN that I might not have thought of. But nevertheless, you know, some discussion points could entail, you know, this synoptic scale versus the mesoscale kind of domain, and how those differ with feature identification. You know, with synoptic scale analysis, it may not capture the more subtle boundaries or features of interest that might be of interest on the WFO scale analyses, in particular of the severe convective side of things. And WPC analysis is updated every 3 hours, which, you know, in some cases that might not refresh fast enough, especially when you're talking about convective events that may require refresh rates of, you know, 2 to 3 times per hour. And then, of course, use in mesoanalysis, you know, aiding in the tracking of potential forcing mechanisms that might be at play. And, you know, that's both the obvious and not so obvious boundaries that might, you know, contribute to, you know, any sort of changing hazards or trajectories of those potential hazards, as well as also aids in the reinforcing of conceptual model expectations. You know, we have these thoughts of how the atmosphere is supposed to work, and then using this PGEN, I think can really help illustrate and reinforce those expectations. And that kind of leads into, you know, this really can be quite a powerful communication tool. Not only just briefing other forecasters, you know, internally in your office, both on your active days and your not so active days, but if you have some of those more meteorological savvy partners, you know, maybe PGEN can be used to supplement your messaging in this particular case. And with that, yeah, I think I'll open it up and send it to Mike.
Carl Jones, hey, thank you so much. That was an awesome presentation. And also thank you to Dylan Flynn. Real quick, before we get too derailed with this good energy going here, I'm going to give you a few messages from our sponsors here. Please note that Tristan is going to paste in the chat here a link for some feedback. Please attend to that if you will. That's going to help the folks at Tower S with getting to know how we're doing out here. Also, if you're at a regional headquarters or if you're in the field and you'd like to ask a question, please do so. Post it in the chat there. Make sure your first and last names are visible. We'd appreciate that. Let's see here. Yeah, looking forward to future presenters. Please let us know if you want to do that. Let's see, one other thing here. Lee posted in the chat there earlier on that there's going to be a Tower S meeting tomorrow, and if you'd like to join that, please take note of the link. A couple other things real quick before we get to Q&A. We do have some questions for you guys, so hang on just a second. In the new year, on Thursday, January 5th at noon Eastern, Pam Sullivan from the GOES-R program will discuss the GOES 18 transition right around the corner, so please stay tuned for that. Also, contact Tower S team, Lee Byerly or Kashad Bowman, for questions about the SBC, SBC for configuration of satellite products. Okay, moving right along here. Carl, Dylan, we've had some folks post in the Q&A here, and we're going to ask you guys a few questions. The first one I saw here as you were presenting, let's see here, Dylan, was from Brian Karan, and he asked if you were using a mouse or a tablet to draw your contours and fronts.
Yeah, that's a great question. I'm just using a mouse, and there's a little trick to it. It takes some learning, but once you get that figured out, it's actually really pretty easy to draw smooth features. All I'm doing is clicking every place I want to put an inflection point. So sometimes that only takes 3 points to draw a nice smooth front. Sometimes it takes more. Isobars take more. And there's a trick to make sure you don't get sharp lines. Like you don't want to put 2 inflection points too close to each other. It may sound like it's hard to draw a smooth line with just a mouse, but it's actually not with the system that PGEN uses.
Okay, so no advanced hardware to help you do that other than the standard old mouse on a mouse pad.
That's right.
Thanks for your question, Brian. Another question came in from Caitlin. Wanted to know if you could share the link, that internal WPC page for the internal WPC page in the chat.
Yeah, sure. I'll do it right now.
We'd appreciate that. Thank you, Caitlin. And Bill had a question. He said, are the final unified surface analyses made available to Weather Service offices for viewing in AWIPS?
That may depend on how your AWIPS is set up. I know that we can view it. It's under the, I think we have like an NCEP tab and it's under that, but I'm not sure if the local offices have that. So it's a possibility, but you may not have it set up.
No, within our office, we only have the WPC surface analysis. So it's just only a portion of the unified forecast. I'm not sure if that's, nationwide. Maybe that depends office to office, but at least within Grand Forks, it's just WPC section.
Okay, moving right along. Tim Schmidt had a question for Carl. As you were presenting, he said it looks like some specialized water vapor color tables were used for those ABI bands, and are those available to everyone in AWIPS, or are those just some locally produced color curves, or what did you have there? I think he was referring to the one where you had the 21Z notation at the top of your slide. Maybe go back another, that one. I think, Tim, is that right?
Yeah, I think it was the one with the 4 panel where you had kind of the purplish colors in the upper 2 frames. Is that just a, yeah, like, so the upper left, is that a standard, or did that look to me, to my like a specialized enhancement or color table?
So that's actually a semi-transparent and a portion of the NAM winds. So this is actually not water vapor imagery. The water vapor imagery is actually underneath these. This is the NAM jet, if you will. It's just kind of meant to only show where the highest winds are, and really supposed to bring focus to the jet portion of the extratropical cyclone. So no special color curves, just some supplemental NWP guidance overlaid on top.
Okay, thanks.
Thanks, Tim, for that question. Bryce Tyner said, great talk. Our TV media partners have consistently stated this type of discussion is welcomed and used in a time crunch environment. So a little comment there from Bryce, thank you. Monica Bozeman for Bill. She was commenting back to Bill and said that the CP team has PGEN training for forecasters. There was a question about, sorry, Bill, just prior, a question about whether PGEN specific training was available to AWIPS users. And Monica did respond there that yes, there is training, and she would take emails if you have questions about that. Let's see here. Go ahead.
I know that I personally was trying to scour CLC, Google shared documents of PGEN training, because I still personally don't feel very proficient in it. There is somewhat of a learning curve, and I just started using it until I got kind of comfortable enough to get where I needed to go. But I would be really interested to grab some training, not only for myself, but to pass along to other colleagues of mine, especially for those who would be interested in the mesoanalysis side of things. I really feel like there's a really great utilization in the mesoanalysis role for PGEN to help illustrate all sorts of things. So yeah, if you could share that with, I don't know, everyone, I would like that.
Thanks, Carl. Hey, a question for Dylan from Scott Lindstrom. How long does an analysis take you?
So that's a good question. And we do 3-hourly, like Carl mentioned, WPC does 3-hourly analysis, and we help them with those. We do south of 30, so essentially Mexico, and we also do Florida, and we combine. So that's every 3 hours. Those take about 90 minutes to do the WPC North American analysis. But the larger one, the unified, we only do every 6 hours. That takes quite a while. It takes about 2 hours and 45 minutes is our deadline. So we start right at the synoptic time, and it takes about an hour or so for everybody to do their analysis, and then a lot of it is connecting it in the borders and sending it out. So it can take 2 hours and 45 minutes is our max time on the unified.
And on that note, how do you deal with collaboration with other national centers and i.e. OPC and such?
Yeah, that's a great question. It's a lot of times it's a cold front that starts in OPC or WPC's area, and we get the tail end down in the tropics, or at least the subtropics. And 9 times out of 10, we just line up. It's really obvious. It's more the subtle features that aren't well defined that sometimes we have a difference of opinion. It's more so with OPC. WPC, we do every 3 hours. So it's hard to get too far off when we're doing an analysis every 3 hours. With OPC, it's every 6 hours. People are changing shifts more often between analysis. So we typically use NWS chat to solve 9 out of 10 problems. If it's more complicated or there's stronger opinions one way or the other, we'll just call. But we're always going to end up with a unanimous decision before we send the map. So it's a good. If you notice a difference in their map while they're working on it, it's a good idea to just kind of build your arguments, find some obs or reasoning, and hopefully they're in the same thing. And then you just kind of have to put your ego aside and realize that you're not doing your PhD dissertation on this. This is an operational product that has to go out. So you just have to come up with a good compromise and go with the best solution. And sometimes that's not yours, but yeah, it's a good lesson in coordination with neighbors.
Hey, I'm going to say if this is a great conversation, I've got a few more questions, and I think a few other people may also have those questions. You can stay on after the recording is ended here, but let's go ahead and ask those who have a few more questions to stay on the line. We're going to wrap things up here and say thank you very much. And Jordan, if you'd like, I'll turn things back over to you for the conclusion, and please stay on for any additional questions and answers.
Sure. Thank you so much, Mike. Really appreciate you facilitating our discussion there, and really appreciate all of the great questions that we got from our field offices and other participants on this call. Of course, thank you to our presenters, Carl and Dylan. It's really great. One of the things that we've been striving for with these satellite book clubs to show more operational examples, and nothing's more operational than doing some of your duties right here on the call. So that was fantastic. As I had mentioned, and as Mike has said, we are off for the next 2 weeks. Happy holidays for those you shift workers on the call that are picking up a shift around the holidays. Really appreciate that, and I hope you're able to enjoy the season when you have a little time off. On Thursday, January 5th, we're going to have Pam Sullivan, the GOES-R System Program Director, is going to be talking about the GOES 18 transition. So if you are particularly at a Western region office, Pacific or Alaska, tune in for that. It's a pretty significant benchmark in the GOES program to have this transition from GOES 17 to GOES 18. Other than that, if you have any questions related to configuration of satellite products or the Satellite Book Club, Lee Byerly or Kashad Bauman, part of our TowerS team, are standing by. And as has already been mentioned, we'll have a TowerS update tomorrow for those interested in everything satellite. So we'll stay on a little bit longer here after we end the recording. If there's a few questions that anybody has, or you want to follow up or talk directly to Dylan and Carl here, we'll continue on for a few more minutes. But other than that, we'll let everybody go. Happy holidays, happy new year, and we'll catch you in 2023. Stay warm, everybody.